right, so for your final example, example number 3, let's go ahead and look at this word problem and see where we're going. Helen purchased 3 books from an online bookstore and received a 20% discount. The shipping cost was $10 and was not discounted. Write an expression that can be used to represent the total amount Helen paid for those 3 books plus the shipping cost. Identify each term, coefficient, constant, and factor of the expression described. Okay, this problem has got a lot going on. Always the first place to start is, what don't I know? Okay, is there a variable and what is it? What does it represent? So I know she purchased 3 books. I know she got a 20% discount. I know she had to pay tax or shipping cost of $10. The thing that I'm looking for that I can't seem to find is, how much did each book cost? Now, one thing we're going to assume here is that she bought them all for the same price. So let's say the cost of the books was X. All right. Now let's start building our expression around that. So how many of those books did she buy? Well, she bought 3 of them. So 3 groups of X, or 3X. Okay, it's a good start. Well, what else do we know about the book purchases? We know that her total cost, the total price of all that, was discounted 20%. Well, discount means you're taking it away from the total cost. So we're subtracting what? 20% of 3X. Again, as in the last example, I want to take that 20% and change it into a decimal. So we're going to do 0.20, okay? Or we can do 0.2, however you want to write it. So 0.2 of what? Well, of the total cost of the books, which again we said was 3X. So 0.2 of 3X. Okay? So that's the total cost of the books minus the discount. And then we had one other piece of information we had to include in our expression, which was the fact that she had to pay $10 for shipping that was not discounted. Okay, so if you're having to pay extra money, we're going to be adding that on to what we already have. So plus the constant of 10. All right, so again, let's talk about each piece. Total cost of the books minus their 20% discount plus our shipping cost. So that looks like an expression that covers the total cost that she's going to have to pay, that Helen will have to pay. Okay, this is going to be kind of like that first example. We got the word problem and we put it together, but now we've got an expression that's not fully simplified. I got x to the first powers, in 2 different places. I got some multiplication going on here that I should be able to handle. So I need to clean this example up before I can start labeling all my parts. So nothing I can really do with the 3x right now, so I'm just going to bring that down. However, I can multiply the 0.2 times the 3 here. Okay, I can clean that up. So 0.2 times 3, okay, turns out to be 0.6. Okay, so 0.6x. And then we have that plus 10 on the end. Now I'm looking at some like terms because we have x to the first power here and x to the first power here. So 3 minus 0.6, we subtract those coefficients, we end up with 2.4x plus 10. Okay, now we have a fully simplified expression and we can start labeling our parts. So again, let's go here and we'll start with terms. Okay, how many terms do we have? How many things are separated by addition or subtraction? 2 things, right? So the terms are 2.4x and the second term is 10. Okay? Next, we want to look at, now I like to do it this way, I'll look at my factors next. Again, factors are terms that contain multiplication. So I look back at my 2 terms that I wrote down. Okay, which one of these contains some multiplication? The first one. What are the things that are multiplied together? 2.4 and x. So those are your factors of that term. Now, there can be multiple terms that each have factors, but in this example, we only have that one term that has multiplication in it, so only 2 factors. Okay? The next thing we want to look at is coefficients. All right, again, coefficients relate to variables. Specifically, what number is being multiplied by a variable. So in this case, we only have the one variable, we only have the x, and the number that's being multiplied by that x is the 2.4. Okay, so that's your only coefficient in this problem. And lastly, do we have any constant? A constant is a term that is a number all by itself. It does not contain any variable or anything else. It's just a constant number that cannot change in the problem. In this case, we go back over here and take a look. That would be the 10. Okay, nothing can change about that. So our constant is 10. All right, now that you've looked at all the examples, go back and watch them as many times as you need. Move on to the next section of the form and answer the questions that go along with this. Okay? Call me if you have questions.